time is the most precious commodity to our customers, and the ability to compress the innovation cycle, compress the delivery cycle, the ability to personalize products for their customers, the ability to have complete freedom in design, which is what one of the things that 3D printing provides, is just going to lead to a whole new revolution in manufacturing and in product innovation, and ultimately much better products for the end user.
Distributed manufacturing is beneficial on numerous fronts. Certainly the notion of a shared design community. We're already seeing that in our tooling and fixture shops. The idea that somebody in Wampu can design a fixture in next day or even shortly thereafter. Someone in our Guadalajara facility can take the best of the design that was done over there and not reinvent the wheel. That's again, fast, lower cost, and is delivering greater value to our factory floor. So there's a number of places where distributed manufacturing and the digital thread enable our factories. But then yes, certainly for our customers and their designers, the idea that you can iterate design faster. I can share a design with you in Vienna. You can send it back to New York. We can compare a physical representation instead of simply doing it on video. There's a lot of value in that. It's not just the cost of flights, right? Because now you have the ability to have virtual teams collaborate in a much, much more rapid fashion.
When we think about 3D printing, we always focus on the printers and the materials, because that's the physical, tangible assets that most people can wrap their eyes around. But what's really important is the digital thread. The ability to seamlessly be able to connect a file to the printer and do it in the most expeditious way is really critical. And when you think about going from making a single SKU to making dozens or thousands of SKUs, being able to manage and manipulate that data quickly is going to be a really important element of 3D printing.
Right now, we're in the first inning of a 9-inning baseball game, maybe extra innings, we'll see. Right now, there are a narrow set of applications that pass the economic and technological litmus test. It's still the case that the vast majority of additive applications are for things like prototyping. But where you look at opportunities for reduced assembly numbers, so if you can take 10 components and put that into one additive design, there's huge savings, there's huge performance gains when you actually put those components into assemblies. So the design freedom, people are taking full advantage of that now, certainly with the MJF technology. Second one is, you mentioned mass customization. We see people certainly in the footwear markets, earbuds and eyeglasses, who are clamoring to get a better fitting, custom or tailored design to either tailored groups or to individuals. There's a lot of benefit there. And then the last one is distinctly the smaller batch sizes for just mass-produced parts. People don't want to have to convince themselves that they have to produce 100,000 or 1 million parts to make it an economically viable product for a consumer. And so those three areas are really driving the markets today. I would anticipate in the next 2 to 5 years that curve will drop radically, and the economies of additive across all the medium, whether it be metal or plastic, will drop precipitously.